Hello, my name is Prince Pal Singh. I am professor of physics. Today we will discuss a problem in kinematics, a problem which deals with non-uniform motion. Here the particle is moving with the acceleration which is not constant throughout the journey. A car starts from rest with an acceleration of 6 meters per second square, which decreases to zero linearly. That is, the acceleration is not constant, and it becomes zero in 10 seconds. After which car continues with the constant speed. We have to find out the time required by the car, for which it travels total 400 meters from the start. So let's see how to proceed this problem. First of all, we will draw the graph of acceleration versus time graph for the first 10 seconds. Initially, the acceleration is 6 meters per second square, and it becomes zero at t equal to 10 seconds. If we write down the equation, that is the acceleration versus time graph, the equation for the acceleration versus time, so we use the intercept form a upon 6. This is the intercept on the acceleration side, and this is the intercept on the time side. So a by 6 plus t by 1, t by 10 is equal to 1. This is the way how we write down the equation of straight line x upon a plus y upon b equal to 1. A and b are the intercepts. So we get, on solving, the acceleration versus time is a equal to 6 minus 3t by 5. From here we will find out the instantaneous velocity. That is, we know that the acceleration is dv by dt. So dv by dt equal to 6 minus 3t by 5. Then we will integrate this equation. It is given that at t equal to 0, the particle start from rest. So at time, the limit of the time is t equal to 0. The limit of the velocity is v equal to 0. Then at time t, let's say the instantaneous velocity is v. On integrating this equation, we get v equal to 6t minus 3t square by 10. We can also find out the velocity at t equal to 10, because after that it continues with the same velocity, which is the velocity at t equal to 10. So the velocity at t equal to 10 will be, if we put t equal to 10 here, 6 into 10 minus 3 into 10 square by 10, that is 30. So ds upon dt, this is the instantaneous velocity, equal to 6t minus 3t square by 10. Again, on integrating this, we will find out the distance travelled by the car in the first 10 seconds, during which it is moving with non-uniform acceleration. So on integrating this and putting the limits, we get the total distance travelled by the particle in the first 10 seconds is 200 meters. Now, after t equal to 10 seconds, it moves with the velocity of 30 meters per second. Because after that the acceleration is 0, the velocity does not changes. In further time t naught, it travels a distance, the constant velocity times the time taken. The further time t naught is taken by the car, so it travels a distance of 30 times t naught. The total distance covered by the particle or the car over here is 200, which it has travelled initially, plus the distance in the further time t naught, that is 30 t naught. This is the total distance travelled. According to the question, the total distance travelled is 400 meters from the start. So 200 plus 30 t naught equal to 400. From here we solve that t naught is equal to 20 by 3 seconds. The total time in which it covers 400 meter is the 10 seconds which is it has taken initially for the non-uniform acceleration plus the remaining time of 20/3 seconds which it has travelled with the uniform speed. So the total time is 50/3 seconds, that is 16.67 seconds. Thank you.